Hi, my name is Logan Hubler, and this is the interactive advanced concept presentation number 7, magnetic fluid. For this experiment, the materials I used were black ink toner, some vegetable oil, and a rare earth magnet. Now I used two different magnets just to test two different magnets to see if one was stronger and produced a better effect. Now unfortunately my experiment did not work. I did not get the needles or like pin looking structures like you were supposed to. That could be because maybe my mixture was too thick, but I tried two separate times and I still didn't get any needles. But I'm going to explain what should have happened and why. So to make the ferrofluid, the process I did was first I poured about 50 milliliters of ink toner into a cup, and then I added 2 tablespoons of vegetable oil. My tablespoon measure is in here, but I don't want to get it out because it'll turn my hands black. 2 tablespoons of vegetable oil to the same cup. I stirred the mixture of the ink toner and the vegetable oil until I got a thin consistency. And again, you want to make sure the consistency of the ink toner and the vegetable oil is thin enough so that the magnet can have the effect and produce the needles. As I said, mine didn't work. Maybe it was my mixture was a little thicker than it was supposed to be, but you want a thin consistency. After it was all mixed up, the vegetable oil and the ink toner, I transferred it to this smaller cup so it was easier to handle, as you can see. So for testing the magnetic fluid, I put the rare earth metal on the bottom of the cup with the ink toner and the vegetable oil, and the liquid was supposed to magnetize. So you go like this, tip it over a little bit, and you're supposed to see the needles come out, but unfortunately mine did not work, as I said. But when you do that, the liquid is supposed to magnetize. The needle-like structures are supposed to pop out. And then I even tested it on the table. I also slid the magnet to the top of the cup to see if the needles would come down from the top of the cup, but that didn't work either. And then when you pull away the magnet, the needles are supposed to fall off or disappear back into the liquid mixture. Also, when you place the rare earth metal under a table and pour the ink toner and vegetable oil mixture over the table, the needles are supposed to form under the table, or above the table, because the magnet is underneath pushing it up, having the needles appear. But as I said, mine did not work, maybe because my mixture was too thick, but that's what's supposed to happen. And the interesting thing about this is you can move around the magnet and the needles still remain, but as soon as you remove the magnet, the needles disappear and it turns into a liquid again. So why the magnetic fluid or ferrofluid occurs? So ferrofluid is a liquid that contains tiny magnetic particles. Its magnetic properties come from the magnetized iron oxide it contains. These particles are known as nanoparticles due to their small size. They're so small that they never fully settle to the bottom of the container. Because of the size of ferrofluids, they don't stay magnetized when removed from the magnetic field. So how the ferrofluids work? These tiny magnets would normally run into each other and stick, but due to the increased surface area in the liquid, this is negated and doesn't allow the magnetite to bunch up and lose its innate properties. Once the surfactant is bonded to the nanoparticle, it is considered a ligand. The ligand also has an attraction to the carrier fluid and pulls the carrier fluid with the nanoparticles as they feel the magnetic force act upon them. So that's what we did in this experiment with the ink toner and the vegetable oil and the rare earth metal. A ferrofluid forms spikes or needles along the magnetic field lines when the magnetic surface force exceeds the stabilizing effects of fluid weight and surface tension. The ferrofluid has a low resistance to flow, so it can function as a liquid O-ring seal, kept in a place with the rare earth magnets. Now, just to talk about some uses of ferrofluid or magnetic fluid. Ferrofluid has been around since the 1960s. NASA was the first to engineer it in order to experiment with manipulating fuel in space. It's commonly used in most computer hard drives and in some speaker systems to reduce heat. So that is why the magnetic field or the ferrofluid works and why the spikes form. As I said, unfortunately, mine did not turn out as it was supposed to. I didn't see any of the needles, but that could be because my mixture was just a little thicker than it's supposed to be, but that is why the needles come out in the ferrofluid and how the magnet works. And that is all. Thank you.